Did you know that a poorly designed network can cost your business thousands in downtime and inefficiencies? Whether it's slow speeds, security breaches, or constant outages, the stakes are high. But what if you could design a network that's not only fast and reliable, but also scalable and secure? In this video, we'll break down the essential components of a computer network, from switches and routers to firewalls and Wi-Fi, and show you how to build a robust network that powers your business 24/7. Ready to transform your network? Let's get started.
To start the course, let's take a look at what a computer network is. Just the word network is a fairly familiar word that we see in many different contexts. For example, we have telephone networks, TV networks, or even more common these days, social networks. Basically, a network is a way to connect multiple components together. Well, in computer science, it connects PCs, printers, servers, phones, and lots of other types of equipment that we'll see throughout the training. Some of the most commonly used components in a company include end devices. These are all the elements at the end of the chain. There are interconnections. These are what connect the equipment to the network. For example, an RJ45 cable or even Wi-Fi interconnections. There are switches. Everything at the end of the chain connects mainly to switches. Before the switches, we had something called hubs. Today, the prices of switches has become so accessible that hubs are no longer used much. A hub works like a switch, except it has lower speed and poor performance. To go back to the components of the network, we have routers. The router connects different networks together while intelligently choosing the best path. Its main function is to route traffic from one network to another. For example, we need a router to connect our home network to the internet. We have Wi-Fi networks. Wi-Fi connects wireless devices such as phones, printers, or tablets to the network using a Wi-Fi hotspot. And there are firewalls. These are security systems that monitor and control all traffic that comes in and out, based on the rules the network administrator has set up. They establish a barrier between their own internal network and an external network, for example, the internet. The internet box that most people have at their home includes 3 components in the same box. 1, it works like a switch, because you can connect PCs to its network ports on the back. 2, it also acts as a Wi-Fi hotspot, because we can connect our phones and tablets. 3, and finally, it behaves like a router by connecting the entire local network to the internet. We'll now turn our attention to the characteristics of a network. When you buy a PC, that is the technical specifications. Well, as with PCs, the technical components of a network can describe its performance and structure. Knowing each of the features of a network helps us better understand how the network is designed and what type of performance we can expect. Among the components to be analyzed are: first, there's topology. There are physical topologies and logical topologies. Physical topology is the arrangement of cables, network equipment, and the elements at the end of the chain. And logical topology is the path on which data is transferred through the network. Another important component is speed. This is the flow, measured in bits per second, for links on the network. It could be 100 megabit, 1 gigabit, or 10 gigabit Ethernet. We have the cost. This includes the general expenditure for purchasing components, installing the network, and maintaining the network. And security, which indicates how the network is protected. Today, safety is very, very important because techniques and practices are constantly and very rapidly evolving. An administrator must review security every time they change the topology of the network. We also have to think about availability. For networks that run 24/7 all year round, availability is calculated by dividing the time they're available by the total time in the year and then multiplying by 100 to get a percentage. For example, 525,600 is the total number of minutes in the year. If the network is unavailable for 15 minutes over a year, then its availability will be 99.9971%. There's scalability. A network must be designed in ways that it can be evolved very easily, because otherwise it will cost much more to add users. And finally, there's reliability. Network components must be reliable to reduce the risk of failure. All these features we've just seen allow us to compare different network solutions.